Welcome to Jeremy's IT Lab. This is a complete course for the CCNA, Cisco Certified Network Associate. In this video, we will look at an essential part of the course, the labs in Cisco Packet Tracer. First of all, what is a lab? In the world of IT, doing labs or labbing refers to hands-on practice with the technology you're studying. Since you're studying for the CCNA, labbing means practicing configuring Cisco routers and switches. There are a few options for CCNA labs. One is to buy actual physical Cisco hardware, real Cisco routers and switches. However, that can be expensive and isn't very convenient. Fortunately, Cisco has an amazing tool called Packet Tracer, which lets you set up simulated networks on your computer. We will be using Packet Tracer for the labs in this course. Packet Tracer is free, quick and easy to set up, and lets you create simulated network labs without having to buy any hardware. The network devices in Packet Tracer aren't real network devices. It's just software designed to simulate network devices, so you can practice configuring them. In this video, we won't actually configure any routers and switches, since we haven't learned any configurations yet in the course. Instead, we'll just get familiar with the Packet Tracer user interface and how to build simple networks. First of all, how can you download Cisco Packet Tracer? You can download it for free from Cisco on this page. Note that I've created a simple redirect link that will take you to this page. It is jitl.jp/packet-tracer. Follow that link and it will take you here. However, first you will probably see this login page. You need a Cisco account to download Packet Tracer, so you can log in here. Or if you don't have an account yet, click on Sign Up at the bottom of this page to create one. Once you have created an account and logged in, my link jitl.jp/packet-tracer will allow you to see this page. First, let me point out that Cisco's learning platform Net Academy has a few courses about how to use Packet Tracer. If you really want to learn how to master Packet Tracer itself, you can take these courses like Getting Started with Cisco Packet Tracer, a short 2-hour course, or the one below it, Exploring Networking with Cisco Packet Tracer. In my course, we won't look at all of the different functionalities of Packet Tracer, just the ones we need to do the labs in my course. So if you are interested in learning more about Packet Tracer, you can take these free courses from Cisco. Anyway, scroll down, and this is where you can download Packet Tracer itself. It is available for Windows in 64-bit and 32-bit versions, as well as Ubuntu and Mac OS. Download the appropriate version for your computer, and install it like any other program. For my course, download the latest version, which is 8.2 at the time I'm making this video. If you have an old version, you might not be able to run some of the labs. Old versions of Packet Tracer can't open lab files made in newer versions of Packet Tracer. However, new versions of Packet Tracer can open lab files made in older versions of Packet Tracer. So if you have the latest version, you should be able to open all of the lab files. Note that when you install Packet Tracer and then open it, you will have to log in to your Cisco account again. After that, you should see my lab file like this if you opened Packet Tracer by clicking on the lab file. If not, just go to the File menu and click Open to open my lab file. In my lab files, the lab instructions will usually be on the left or bottom of the screen, and then there will be some devices I've already placed in the network. In this first lab, there is just one router, which I have named the Internet. Then, the lab instructions tell us to place the other devices to make a network. Note that throughout the course, I expect that you will be using my pre-made lab files to do your labs. You are free to make the labs yourself from scratch without downloading my lab files, but that won't work for all of my labs. Some labs in the course require troubleshooting. In those labs, I purposefully made some configuration mistakes, so it's your job to find those mistakes and fix them. Okay, before we go through the lab instructions for this first lab, I want to show you the Packet Tracer Preferences menu. Go to Options in the top menu, and then Preferences. In this first tab, the Interface tab, you can select things like whether or not device model labels are shown. I usually have this off, but if I turn it on, notice that above the Internet, 2911 appears. That is the model name of this router. It's a Cisco 2911 router. I just named it the Internet to represent the Internet. I prefer to have device model labels off, so I'll remove this. If you don't want to show the device name, you could uncheck this here too, but I think it's best to leave the names on. Anyway, feel free to check out some of these other settings if you want. I just want to point out one more tab, that is the Font tab. Here you can change the font sizes in Packet Tracer. For example, all of the menu font sizes, or the font size in the device's command line interface. To make it easier to see in the videos, I set the font sizes fairly large, but feel free to set whatever size you prefer. You can also change the font colors. For example, if you want to feel like you're in the Matrix, change the Router iOS text to green, and the Router iOS background to black. Then hit Apply and Exit. Then click on the Internet router, and go to the CLI tab. And hey, now you're officially a hacker. CLI stands for Command Line Interface, by the way. This is how we are going to be configuring routers and switches in the course. Anyway, I'll exit from here, and let's actually do this first lab, which involves recreating the network displayed at 16 minutes and 40 seconds of the Day 1 lecture video about network devices. Here's that network. In the middle, there is the Internet. In this lab, I'm just using a router to represent the Internet. Then there is the New York branch on the left with some PCs, a switch, a router, and a firewall. And in the Tokyo branch, there are 2 servers, a switch, a firewall, and a router. Also, somewhere over the Internet, there is an attacker. Okay, so let's recreate that network. For the routers, the instructions say to use Cisco 2911 routers, the same kind of router I used for the Internet. To place a device in Packet Tracer, go to the bottom left here, and click on this icon for network devices, and then routers. Then you can see a selection of router models. Let's select the 2911, and place 2 of them in the network. This is what a Cisco ISR 2911 router looks like, by the way. ISR is a line of Cisco routers, and 2911 is a particular model in that line. Okay, next let's go to the switches menu here, and place 2 2960 switches in the network. Here's a photo of a Cisco Catalyst 2960 switch, by the way. Catalyst is the name of a line of Cisco switch models, and 2960 is one model within that line. Okay, next we'll place the 2 firewalls by going to the firewall menu and placing 2 5505 firewalls. Note that in the network diagram in the Day 1 lecture video, the New York branch firewall is between the router and the Internet, and the Tokyo branch firewall is between the router and the switch. Depending on the network design, you might find the firewall placed in either position. This is a photo of a Cisco ASA 5505 firewall. ASA is a series of firewalls made by Cisco, and 5505 is a particular model within the ASA line. Okay, now let's place the end devices like PCs and servers. Go to the End Devices menu, and here in the End Devices tab, we can find PCs, servers, etc. So, place 2 PCs in the New York branch, and 2 servers in the Tokyo branch. Then, to represent the attacker in the diagram, place a laptop. Okay, now all of the devices are placed. This isn't in the lab instructions, but let's rename them to match the diagram in the lecture video. To rename a device, just click on the device name. PC1 already has the correct name, so I'll start on PC2, then Switch 1, then R1, then Firewall 1, then R2, then Firewall 2, then Switch 2, then Server 1, then Server 2, and finally the attacker. Okay, now we've placed and named all of the devices. To connect devices in Packet Tracer, click on this lightning bolt icon here. Now, in the next video of the course, we will study different types of cables used to connect devices together in a network. So for this video, we will just let PacketTracer pick the cables for us by clicking this lightning bolt which says automatically choose connection type. So I'll click on that, click on PC1, and then click on switch 1. And now they are connected. Then I'll do the same to connect PC2 to switch 1. Now here's a trick to speed things up. Hold down the Control key on your keyboard and click on the lightning bolt. Then I'll connect switch 1 to R1. But notice after connecting them, I don't have to click the lightning bolt again. It is still selected because I held down Control while clicking it. So I'll connect R1 to Firewall 1, Firewall 1 to the Internet to R2, R2 to Firewall 2, Firewall 2 to Switch 2, Switch 2 to Server 1, Switch 2 to Server 2, and finally the attacker to the Internet. Now they're all connected, so I'll click Cancel here, since I don't need to do any more connections. Okay, we're done with the lab instructions. We have successfully recreated the network diagram as shown in the lecture videos. Most days of the course will include a PacketTracer lab, so you can practice configuring Cisco routers and switches. Ideally, you should try to complete the lab on your own in PacketTracer after watching the lecture video. Then, you can check my lab video after to confirm your solutions. However, if you're having trouble doing the practice labs on your own, feel free to watch each lab video before actually trying the lab in PacketTracer. That's not a problem. The important thing is that you get hands-on practice with Cisco routers and switches to deepen your understanding of the concepts we cover in the course, and also to prepare for the exam. Okay, that's all for this video. I hope it was helpful. Thanks for watching.